The temperature of a body is increased from minus 73 degrees Celsius to 327 degrees Celsius. The ratio of emissive power is. So the temperature in first situation is given as minus 73. So if you are adding with 273, we can convert it into Kelvin scale. So we'll get the answer as nothing but 200 Kelvin, and the temperature in second situation is given as nothing but 327. So if you are adding with 273, then you'll get the answer as nothing but 600 Kelvin. So we can say that the temperature is changes from 200 to 600 Kelvin. Then the ratio of emissive power is. So our aim is to find out the ratio of emissive power. So sometimes we'll use this word emissive power for emissivity. Over here in this question, they are not discussing about that. I would like to say that the power radiated by the object, the power of emission. So we can write the value of, they are not talking about E, they are talking about P. So we can write the ratio of power emitted is P1 divided by P2, as we know that the value of P is equal to nothing but E sigma A, temperature of object raised to 4. So we can write this P is directly proportional to 4. So P1 by P2 is nothing but temperature of object in the first situation by temperature of object in second situation raised to 4. So you can write this as basically 200 divided by 600 raised to 4, or you can write it as, if you are cancelling this, we'll get as 1 by 3 raised to 4. So 1 by 3 raised to 4, we can take it as 1 divided by 81.